System design practice time. In this video, I'm going to cover a system design question called design search autocomplete system. So let's get started. So for this question, it seems to be quite specific, but actually it's not as it looks like. So there are a lot of ambiguities here. So first of all, we still need to ask some questions to scope the problem, to define some good feature requests and some non-goals. So my first question would be, what is the character set of the auto-completion system? Because it's very different from like supporting English only or supporting like Japanese, Chinese, Korean, Russian. So it will be very different. So let's say we are only building something that is supporting English. So non-English, we are not going to support that. And also there could be some other things we need to consider. So for example, localization. Because for different area, like for England and for America, the popular queries could be very different. So my next question is, are we trying to build something like, are we trying to build a unified auto completion system, or are we also trying to consider the popularity of the query from the local country, like the localization? So let's say we are just going to build one system to support all the auto complete queries, localization, etc. Is not supported, like localization. And also there might be some other questions. For example, how many of the queries are we going to, how many of the autocomplete results are we going to return? So let's say we are trying to return the top 10, let's say the top 10. When we say top 10, what is a top? How do we define the top? That would be another question. So let's say it is solely based on the popularity, or which is the frequency of the queries. So queries. So those are the questions I want to first bring up. There might be some other questions, but currently I think we have a pretty small scope, a pretty smaller scope here, which we could start to design something. So currently, as we see, we are just designing one system, which means we just need to build one system. We don't need to care about like the localization. We don't need to have different statistics to support different locations. Just one system to support all the auto completion queries, and each query is going to return the top 10, and we are only supporting English. So that's pretty clear stuff, and I think we are good to go to start the next step. So the next step usually is to do some constraints analysis. So in this step, usually we try to think about the traffic, like the QPS stuff, and the storage part, and also some other things like availability, scalability, like durability, like the latency stuff, etc. So for this part, it is trying to help us to analyze what is the scale of the system, what system are we trying to design, because it's very different from designing something demo, comparing to design some highly distributed system. And also another thing is it can help us try to understand what the bottleneck is for this system design. So usually when you understand the bottleneck and you can use some good ways to solve the bottleneck, I would say it is you have like a pretty good success for the system design interview question. So for traffic, let's say I would say how many daily active users do we have? Let's say we are targeting the first 100 million daily active users. So let's say each user is going to initiate one query to the search engine, and each query is of the length, let's say 5 characters in average, which means we are going to initiate 5 queries to autocomplete system. So having said that, it is 100 million data active user, and each user is going to initiate 5 queries to our auto completion system, which means we have 500 million queries per day. So 500 million queries per day means let's say 500 million, so 24 hours, 3,600. So it is something like 5 or 6,000. So 6,000, it's not that much, I would say. Okay, so let's say this is 6k, so it's 6k QPS, and let's say for the peak time we triple it, let's say 18k for the peak QPS. And depending on the expensiveness of the query, I would say this type of query is pretty cheap in my point of view. So usually like a normal server can hold like 1k QPS very easily. So it's not a bunch of the machines we need here to build this kind of system. And this mostly is about the traffic stuff and the storage part. So for the storage part, we are only supporting the English stuff. So depending on our data structure, so let's say we are using some prefix tree or trie structure. So how to store that? How to store the trie though? So to store the trie, usually I think it's okay to store the tree data structure, but it is going to introduce a lot of the hassle for the search time when we just store the trie data structure. So instead, let's say we are storing the trie using some key value pair. So the key would be the prefix, and the value is the top 10 queries. So let's say each top 10 for the top 10 query, the average of that is 10 cars per query. So it's like for each of the key we have 100 characters average. So let's say how much of the prefix do we have? How many of the prefix do we have? Let's say the prefix we have here is let's say the length is maybe in average it is, it's not in average, but here it is how much we need to consider for the storage. Let's say this one it is 10. So for 10, suppose the length is 10, then it means at most is 26 to the power of 10. So let's use some so it's like 2 to the power of 10 times 10 to the power of 10. So it's like 1k times so this 1k, 1 megabytes, 1 gigabytes, 1 GB, So it's like 10k times 1 GB, something like that. So it is going to be 10. So this is 10 TB, 10 TB, and we have 100 cars, which means it's like 1 petabytes. So it's like 1 petabytes of the storage in total. But I would say usually it is less than that, because it is, I wouldn't say like for each of the position we have 26 possibility. It should be less, way less than that. But I would say worst case, let's assume we are targeting about the 1 PB of the data storage part for this key value pair. Oh, okay. So I think I forgot to store how many of the key value pairs are there. So we have 26 to the power of 10. So this is like some estimation. It's about, so if I say it is actually 2 times 10, and then to the power of 10, which is something like this. So for this one, we have how many key value pairs are there? How many keys are there? So actually we have 1 TB. Okay, so it's 1 TB. It's like, sorry, 10 trillion. It's like 10 trillion of 10 trillion of the key there. So 10 trillion of the key, we are targeting the total storage about 1 PB. So I think that's mostly about the storage part. And for availability, let's say we are targeting about 3 nines here, which means it is like for each here there is like a couple minutes of the downtime. So let's say for the scalability, we need to design a highly scalable system. And also for the durability, so not losing data. So for the latency, let's assume like for 99% of the queries, let's say 99% of the queries, it should be smaller than 200 milliseconds for the autocomplete. So having said that, I think we have a pretty good, we have collected pretty good numbers. The traffic is, we are targeting like 18k for the peak time QPS, and also we have 1 petabytes of the data for the storage. Key value pair, we are targeting about 10 trillion. Yeah, so that should be pretty much it for this part. And the next part is about design overview. So for design overview here, we need to define the general data flow, and also we need to think about the different components we are having here, and the dependency among different components, data flow among different components, so something like that. So let's say I'm a user and I send a HTTP request to the service. So first of all, via the DNS, we find the IP address for the service. We are going to first hit the load balancer, and then we are getting so do we actually have any web service? Yeah, I think we do have like for the Google web page, it's like the front-end server, and the front-end server is going to and by the way, we are only talking about the auto completion system. So the front-end server is going to send some RPC requests to the backend server. So the backend, and also by the way, this is not like a single server. It's a bunch of the servers hide behind the load balancer. And also the backend server is going to try to query the DB. And before the DB, usually there is a cache layer sitting on top of it. And also to avoid any single point of failure, this one is a bunch of workers sitting behind the load balancer, and cache is distributed cache. For DB, we need to make sure we have some duplication, let's say master slave stuff. And also, it's pretty natural for our use case to use NoSQL here due to because we choose to store try using some key value pair. And also we have a large volume of the key value pairs, so that's why we essentially choose to use NoSQL here for better scalability. And this mostly is about the service part, which is to query, like when you send a query, we return the top 10 autocomplete results. But there is some other parts, like for the DB, how are we how can we how can we compute, like for the DB, where is the try data structure from? So where are the key value pairs from? So the key value pair, let's say for the DB, of course it is let's say we have some batch jobs. Let's say it is some MapReduce jobs. So the MapReduce jobs is going to consume the log. So the log is collected by our let's say the server. I'm not sure how to call it, which server we should call it. Let's say that is the query server. So the query server, let's say every time you send it to our front end, okay, so I think I know that. So every time you send the HTTP request to the load balancer, including the stuff of the prefix, and it's going to hit our backend server. And finally, let's say you get a query, there. You select one query and then you initiate a query. So we are going to collect the query into our log using some redirection. So first of all, before landing to the search result page, it is going to go through our let's say query server. So the query server is going to collect a bunch of the information, including the query itself, like the timestamp, etc. And it is going to store into our log, and we have some batch job, like MapReduce job, consuming the log, and also write the key value pairs into our database. So that's pretty much about the two parts. The first part is about the search service part, and the second part is about how to say that. It is about statistics. It's about generating different statistics. Like for each key value pair, for each prefix, we need to compute the top 10 queries and then store it into the DB. So that's mostly about the general infrastructure, about the overall design for this. Let's go to the next part, which is about design details part. So for the design detail part, usually we need to it really depends on the user, the interviewer's interest. Maybe he is going to lead you to the data storage layer. Maybe he's going to lead you into like the business logic layer, or like monitoring, etc. It really depends. But let's go through each of the component and briefly introduce what it is and why it is scalable, etc. So usually, I wouldn't feel surprised if the interviewer ask about like the DB, the data schema, the table design, and what columns, which kind of database you're going to use, something like that. Like for DB, we are going to use NoSQL. That's pretty clear here, because for each of the prefix we are going to store like the top 10 queries. It's like a key value pair, very natural, and we have 10 trillion of the key value pairs. It's large volume, For better scalability, we just use NumSQL. Let's say there are a couple different NumSQLs we could use. Let's say we just use Bigtable here. So for Bigtable, you know that, and it's very natural here as well. So you have the key, 0 key as a prefix, and you have the define the column family. So for the column, you only have column family, you only have one column. And it's going to store a protobuffer. So the protobuffer stores, let's say, it stores the top 10 queries. So maybe we also need to store the corresponding frequency, but I think currently I don't think there's any use for our simple use case, but you may need to store some more data here, but currently I think there's no use. Just need to store the corresponding top 10 queries here. So that's about the data schema. You see that it's very something very easy stuff. So, and also for the DB part, we need to care about the data duplication and the scalability. So for duplication, we will need to have some master slave stuff. So for master slave, we have some different slave setup. So for different purposes. The first purpose is we have the duplication of the data, and the second purpose is we deploy the data center around the world. So when one query, suppose one query comes from England, and we have the data center in both England and the U.S., then the query against the data storage part is going to come to the data center in England. So if we have a slave set up in that corresponding data center, and so that part is about data duplication, and also for data sharding, I think it's also quite clear, because we are using NumSQL and we are using Bigtable. So sharding, we don't need to worry much about that. It's mostly based on the row key though. And the next thing is if there, it is very, I would say it would be very slow if we do a DB query. Like every time we have a prefix, we query against the Bigtable for the prefix and get the top 10 queries. It will be very slow, and also there could be some hot queries. So the way we try to solve this is we introduce a cache layer. So this cache layer is going to try to cache the top prefix there. Suppose we have the corresponding prefix in the cache, then we don't need to query against DB for that. So this is going to reduce the burden on the DB and also speed up the query result. And also for the cache, there are a lot of different choices, but let's say we just use memcached to build a distributed cache. So cache is memcached, and also what is the key value? So of course the key is the prefix value is the top 10 queries. And for the cache, we also need to think about like a cache invalidation, because we actually update this DB from time to time. So we also need to think about this cache invalidation. Let's say we just invalidate the cache every 1 hour, etc. And also we use LIU cache to make sure that it doesn't overflow the capacity, etc. So that should be pretty much it. And also for this system, it is worth to mention that it's not for the consistency side, it's not 100% consistent. That's because we have the cache layer, and also when we update the DB, we have the master slave structure set up here, so it is very likely for the master and slave to have different data. But overall, I think for the business purpose perspective, I think for the business requirement, I think it should be able to satisfy that. That is because, for example, let's say, suppose there are 100, let's say there are millions of trillions of the web pages there, and when you do a search query, you search something, you just look at the like at most like top 10 pages for most of the people. So actually, you don't need to have the recall to be 100%. So similar for this case. For this case, we don't require the auto completion result to be always consistent. So yeah, so I think that should be a very good decision here. So we don't really need the always consistent among different queries at different time, etc. So that's the DB and the cache, and for the backend server, it's just a normal backend server receiving the RPC request there, and try to query cache. If cache is cache missed, then try to query DB, and then update the cache. So not too much to talk about the backend server. Frontend server, it's okay. It's yeah, I think not too much either. So for the load balancer, I think load balancer could be a single point of failure here if we only have one. So instead, what we could do is we could have two load balancers here listening to each other, like a master and slave stuff. When the master load balancer is down, then the other one will be elected as master, and for all the time, the two load balancer send heartbeat signals to each other and listen to each other to make sure that there is one load balancer there alive. So the next part, let's say that for DB, we already talked about that. For the MapReduce job, so it's about the so it is very common for some companies to run against some MapReduce job and do some log analysis and store the results somewhere. And in your case, it is like a scan through it's like consuming the logs. Let's say for the last 10 days, maybe. Let's say for the last 10 days, consume the last 10 days of query, and then try to generate for each of the prefix, try to generate the top 10 queries. So that's pretty much it, I would say, at this moment about the system design. So I think there could be some other follow-up questions. So for example, what if I want to support languages other than English? So if it is other than English, you can also just change the key instead of ASCII, so it is Unicode. And what about we want to have localized search auto-completion result? So then for that one, you will need to, so for the log, you will have the location stuff, and you need to build different try, and based on the user's location, and you select the corresponding you use the corresponding try to return the localized result, it's auto completion result. And what else that could be potentially the interior could ask? So maybe because so like we said, we are using some MapReduce job, like a cron MapReduce job to run it regularly to analyze a log. So for some, let's say for some news, let's say a breaking news just happen within 1 minute. So for this kind of system design, it is not going to cover the trend. It's not going to cover the trend of it. So there are a couple different ways to mitigate this issue. So for example, we can change the logic in the MapReduce job to make sure that we assign the bigger weight to a more recent query, so that more recent query can get a bigger weight, which means more recent query tends to appear in the top 10 queries more often. And also for some news break, let's say we could also build some streaming processing pipeline to update to do some updates, but yeah, so some streaming pipeline, but we also need to consider about the general logic about the streaming pipeline though. Yeah, but it really depends. If the interior want to dig into that direction, we may need to think more about that. But overall, I think we are in good shape about this system design question. Like what we did, first scope the question, define feature request, clear about the non-goals we are not going to support, and do some constraints analysis, collecting some numbers to understand where the bottleneck is, and what the scale of the system, and collecting some SLs here. And the next step, doing some design overview, just introduce the components we are going to have, and the interactions among different components, and try to make sure that this kind of stuff is scalable enough. And the next part, depending on the user, depending on the interviewer's interest, lead you into different parts, but don't be afraid. So as much as just talk as much as you know, but if you don't know, it's okay, because different people have different expertise. Just talk in a way like, well, I've heard about something, but I don't have like very deep expertise in that area, so that should be fine. So that's it for this system design interview question. So if you like it, feel free to leave. If you like it, please help subscribe this channel. So I'll see you next time. Thanks for watching.